So Dr. Lee is a professor, School of Computer Science and Mathematics, Liverpool, John Murray University, UK. He is also adjunct professor, KAST Institute for IT Convergence, Republic of Korea. He is holding the post of the ITUT chair for the focus group on data processing and management to support IoT and smart cities and communities. His research interests include Internet of Things, digital twin, computation trust, knowledge-centric networking, and services considering all vertical services, smart grid, energy saving networks. So once again, I welcome Dr. Myoung. Now platform is hand over to Dr. Lee. Please, you can share your presentation also.
Thank you. So thank you very much for introducing me. So I'm very honored to be here as a speaker. I believe you can hear my voice. So then I would like to start my presentation. So my presentation topic is standardization on quantum key distribution networks in ITOT. I would like to introduce lesson. Sorry, can you hear my voice? So I would like to introduce relevant.
It's audible, please go ahead.
Yeah, relevant technical.
You are not audible. Dr. Lee, please.
Yes, can you hear my voice?
Yes, Dr. Lee, it is audible.
Yeah, so based on this topic, today's talk, I wanted to briefly.
You are not audible.
Sorry? So here's the first slide regarding quantum key. Yes, so quantum key distribution. So probably you heard this technical term. So basically, in the QKD, so quantum key distribution, this one is one of the important technology to support secure communication. So traditionally, we have considered to support QKD module in a system. Then between two different nodes, we successfully conducted the relevant experience to exchange keys by using QKD. So based on this technology, recently there is strong demand to support large-scale networks with so many number of QKD systems. So in this regard, like this kind of manner, from QKD system, now we are talking about QKD networks. So in this regard, in ITOT, this is a standardization body for global interoperability. So there are relevant activities to consider quantum key distribution networks. Particularly, study group 13 in ITOT, there is a group for supporting network-related technologies. So in this regard, I would like to introduce key result of study group 13. So as you can see here, we started to develop QKD-related technological solutions as a standard through, I think, about 3 years before. So at the time, we postally started to develop overview document. As you can see here, Y.3800, this one is an overview on networks supporting QKD. So this is the starting point to address various kinds of networking technologies by using QKD. Based on this document, study group 13 in ITOT has developed so many number of documents. As you can see here, quite a fundamental document regarding requirement and architecture. And then we also developed more detailed technical solutions, such as key management, control and management for QKDN. And then also there are several documents regarding software-defined networks, business role-based models, and many QKD-related aspects also. Particularly recently, we are also working on how to support machine learning technologies in order to improve network performance. So in this regard, the first document, Overview on Networks Supporting Content Key Distribution, we fundamentally define various kind of key elements and then show a concept to support QKD. So as you can see here, underlying networks, there are several different nodes with a QKD, and then user networks. This is a kind of conventional networks, currently 4G or 5G. So then in the network application, so we can support cryptographic applications in support of QKDN. So when we first developed this document, we concentrate on to provide a reference architecture. So as you can see here, in the QKD part, there are three different layers: quantum layer, key management layer, and the QKDN control layer. And then quantum layer, there are several physical nodes, receiver and transmitter. And then key management part, this is a core part for manipulating quantum key. And then in the control part, there are controllers and the manager. And then in the service part, also we are thinking about applications. So this kind of manner, we identified several basic functions like a quantum key generation, key management, QKDN control and management. So based on this one, next document is requirement, and then Y.3802 is QKDN functional architecture. So previously, I just briefly showed a reference architecture. This one is a very, very abstracted diagram, but in the architect's document, here you can see there are lots of detailed functional components. So we already identified detailed functional sets and then description of an individual function based on this functional architecture. So then we started to show so many different technical elements. So actually the core part of our QKDN is quantum key management. So in this regard, in Y.3803, this document describes key management for QKD, particularly in the here inside the key management, we can see two parts: key supply and then key relay. So including key storage. So this kind of manner with the interaction over QKD module and then cryptographic applications. So there are lots of processing in the here. So we identified various kind of operational issues, including procedure. And then also considered more detailed functions in the control and the management layer. So as you can see here, QKDN controller and then QKDN management layer, there are several functions. Because we are considering large-scale networks, there are many different nodes. So the fundamental issue is how to manage this kind of networks in terms of control and management perspectives. So that's the reason why we have identified various kind of new functions, as you can see in here. And then now I would like to introduce another aspect. So for network control and management, software-defined networking technology is popularly using in networks. So in this regard, we also considered how to adopt software-defined networking concept. So in this regard, in Y.3805, this document specify many relevant aspects, especially to support SDN-enabled network solutions. Actually, as you can see in here, SDN is a core part of our network control. So in this regard, QKDN control layer, there are several functions. As you can see in here, there are highlighted part. And then another important thing is that in order to efficiently support large-scale networks, we need to think about hierarchical network architecture. So as you can see here, there is several server networks can be considered intermediate controller, and then here there is a central controller. So that kind of manner we have identified hierarchical SDN like this, and then also defined relevant functional interfaces. So I believe this is a really good starting point to show more realistic technical solutions to be commercialized in the market. Quite similarly, we also considered to support other technical points. So now I would like to illustrate secure storage networks. So in a user network part, we are considering storage networks like here. So if we wanted to consider to use QKDN as an underlying network technology like here, how we interconnect with the user's networks with the PKI concepts for security reasons. So that's the key element over this scenario. And then in here, you can see detailed functional architecture for SSN. And then another important thing is from network operator's point of view, they wanted to find concrete idea how they can develop relevant business. It means that how they can successfully deploy this kind of network equipment and then support related applications. So in this regard, Y.3809, this document illustrates detailed business rules based models. There are different providers like here, and then they can consider various kind of interactions and then provide detailed scenarios for real deployment. Actually, this one is one of the important areas. So as I already illustrated in the previous document, so we are considering to support layered concepts from quantum layer, key management layer, and the QKDN control layer, and the management layer. So based on this kind of layered concept, and then considering use network part, these kind of all relevant technical items are interconnected with the various kind of business models. So I believe this one is quite useful to successfully deploy the technology. Now I would like to introduce another aspect. So there are lots of demand to consider AI-related solutions recently. So in a network part, there are lots of always demand to consider various kind of AI-related solutions. So in this regard, for QKDN, there are also strong demand to support machine learning functions. So in a machine learning functions, there are relevant key components. Then these functions can support and facilitate the relevant actions based on predictions. So in this regard, firstly, we identified several use cases. So this document contains detailed use cases. So I believe here is the list of relevant use cases. First one is content layer part, there are 3 use cases, and then key management part, also several use cases by using machine learning, and then control and management point of view, data collection, data pre-processing, routing, and point predictions. These kind of aspects are quite important element as a use cases. So after successfully identifying these kind of use cases, we also currently developing one document, wider QKD and FRA. So this one is mainly consider another architectural methods for machine learning. So there are lots of elements to support machine learning. So as you can see here, this document identify role over machine learning and the functional requirement and the architecture. So this is just the initial version of the architecture. So we are continue to update this architecture. And then I also would like to illustrate the several other activities based on the previous attempt. So apart from very fundamental functions from the network perspectives, so we can also consider many other technical areas. So here, one consideration is resilience framework. So network resilience point of view, there are many issues. For example, protection of key supply and recovery. So these kind of resilience issues have been identified as an important item. So we intend to develop detailed requirements and provide use cases. Quite similarly, recently we also well identified the necessity of interworking. So instead of just one provider, so we could consider several multiple providers. So then how we interconnect, this is a really fundamental point. So in this regard, we started to develop interworking framework documents. So this document basically cover interworking aspect between QKDNs supported by different QKDN providers. So we can consider various kind of scenarios for interworking, but in here, just simply mentioned here, various kind of different technological solutions also can be considered. So in case of different QKDN providers, it's very clear. So we can consider to support one-to-one interworking between two providers. But even some case in one provider, they have different products, different equipment, or different protocols. So then there are lots of demand to successfully support interworking. So as you can see here, basically we can consider to support different technical aspects. So multiple solutions can be deployed in administrative areas. So then we need to think about interworking. And then in order to successfully develop this kind of technical solutions, we also started to develop roadmap document. So this roadmap document provides a landscape and related technical areas. So we continue to collect quite important technical items and then provide the detailed standard for many operators. So I believe this one is quite good to provide guidance for many different stakeholders. So based on this one, now I would like to also shortly introduce QKD related aspect, but more relevant aspect for quality of service. You know, from network point of view, quality of service is really fundamental aspect. It's very important topics. So we already well identified and well recognized the importance of this topic. So as you can see here, we started to develop requirement poster. So this one illustrates relevant functional requirements. Especially this document identified various kind of different domain and then try to support end-to-end QoS. So this is the QoS related topic. And then accordingly, question 6 of study group 13, this group have developed and still developing several different documents under the QoS methods over QKDN. So, for example, wider QKDN QSPA, this one is quantum key distribution networks on QoS parameters aspect. So they started to identify and describe QoS and the NP relationship, and then provide detailed QoS parameters. Quite similarly, there are a couple of documents on different topics, such as functional architecture of QoS assurance, requirement of machine learning, but this machine learning is targeted for QoS assurance methods. So this kind of aspect are currently considered in ITOT study group 13. So I believe I have illustrated most of the all important aspect of the networking part in ITOT study group 13. And then there is another group in ITOT for developing quantum information technologies for networks. So actually QIT4N stands for quantum information technology for networks. So there is a separate group as a focus group. So this one is working on pre-standardization activities. So before developing relevant recommendations formally, so there is another group, like a focus group. They are targeting to develop relevant deliverables. So actually, this group was created 2 years before, and then they recently concluded the activities. So I would like to introduce this group's activity. So as you can see here, quantum information technologies. So it's a little broad concept rather than just the quantum key distribution networks. So as you can see here, in the quantum internet, we can cover several components, such as the quantum computing, quantum communication, quantum sensing, and methodology. So this kind of manner, many standardization bodies try to support relevant activities to develop standards. So QIT4N is one of our activities. As you can see here, apart from only ITOT, there are many different organizations, such as IETF, IEEE, and then ISO, IEC, etc. So you can see quite strong, quite relevant information. So, for example, Etsy, they started to develop relevant technology really more than 10 years before. So QKD itself is not a new technology at this stage, but recently, based on quite significant advances, we started to consider to develop network-related solutions. So in this regard, from the various kind of a technical point of view, so you can see relevant information like here. So quantum computing area and the quantum internet area and the quantum key distribution area. So focus group QIT4N, considering mostly QKDN, but beyond QKDN, so they also well identified various kind of emerging technical areas, such as a quantum internet. So currently in IETF, especially there is a research group, quantum internet research group. So they are working on to develop architecture and the detailed principles, including use cases. So that kind of activities are currently working. So actually, recently ITUT, we also newly started to consider quantum enhanced future networks. It's slightly different point, but basically most of our standardization bodies, they want to continue to develop relevant standard to cover these kind of areas. So now I just show you some information of FG QIT So 3 working groups, they mainly consider 2 different aspects. One is network aspect of QIT, and the other one is QKDN. So based on 2 different groups, they started to develop relevant technical solutions like here. So please see some more information. Actually, if you go to website of FG QIT so you can find more detailed information. So actually, they produced several documents. So as you can see here, for working group 0 and working group 1, as I indicated here, network aspect of QIT, more advanced part compared to QKDN. So they have developed 5 deliverables. So landscape, outlook, and terminology, use case, implication of quantum information technology on networks, and lastly, standardization, outlook, and technology maturity. So mostly these are somewhat theoretical and somewhat fundamental aspect instead of specifying relevant technical solutions. But I believe these are quite important inputs for developing relevant standard in the future. Quite similarly, in case of QKDN part, working group 2, they have developed several documents, as you can see here, for QKDN, terminology, use case, protocols, transport technologies, and then the same document, standardization outlook and technology maturity. So these kind of documents have been developed in working group 2 in QIT. So if you really wanted to see more detailed information, please check the individual document. For example, for QKDN use cases, so you can see several different use cases for QKDN. And then QKDN protocol point of view, there are also detailed protocol solutions. So you can see relevant protocols. And then transport point of view, currently we haven't well considered all the details, but currently in the transport areas, such as optical communication part or optical networks, so they probably need to support quantum key distribution by using various kind of existing optical network infrastructures. So that kind of issues also can be identified like here. So this is just a summary of some information. So please check all the details in the individual document. So now I would like to consider to summarize some important findings. So actually, ITUT, from this year, we start a new study period for next 3 years, I believe. So then QKDN is really important areas. So we intend to develop additional QKDN recommendations. And then quantum enhanced networks and services are also very important areas as a continuation of QKDN activities. So ITUT study 13 point of view, we wanted to collect focus group result and then think about new technological solutions for supporting quantum enhanced networks, as well as use networks and related cryptographic applications. So based on this one, I would like to conclude my talk. So in the short term in ITOT, we definitely need to focus on standardizations on QKDN. So there are lots of issues, such as scale up from QKD system to QKD networks, enhancement of available technologies for key management, and new technical solutions for control and management especially, and then several interworking issues. Based on this kind of a short-term approach, we are also thinking about a long-term approach to standards, especially on quantum-enabled future networks or quantum-enhanced networks and services. Basically, we are thinking about how we integrate QKD technology into various kinds of different networks, like 5G. We can also think about 6G, and then we could consider so many number of emerging technological solutions, such as quantum computing and the quantum internet. So that kind of things need to be considered from the standardization point of view. Thank you so much. This is the end of my talk. So thank you.
Thank you, Professor, for your detailed presentation on quantum key distribution network in ITOT. Really very informative and thought-provoking presentation. Heading the AI science group at IBM Research Center. He is an IBM master inventor with 34 granted patent and over 150 research publication. His present goal is to set up a quantum computing ad, as a leading area of research in India. Now, stage is hand over to Mr. Venkata. Please.
Thank you so much. Can I share?
Yes, please.
Okay, it's not yet enabled, so I'm just waiting for it to be.
Yeah, please.
Okay, thank you so much. Just 1 second. Okay, good afternoon, everyone. Are you able to see my screen?
Yes, we are able to.
Okay, thanks. So thank you so much for having me in this talk here today. So I'm going to be talking about, the technology maturity and how, we as individuals, as government officials, as industry, how we are preparing for this quantum era. So as we saw, in some of the previous talks, quantum actually talks about various technologies, right? So there is quantum cryptography, there is quantum computing, there is quantum sensing, then there is quantum communications, and there is the quantum systems and hardware, right? So there are various aspects, and there is these technologies are right now developing at a very, very rapid pace. And what, as a country, as India, what we should do is we need to match this pace and see how we can lead it, right? So today's talk is really about, as you saw, it's going to be about what is the maturity level of the technology, what is the maturity level of the ecosystem in India, and how can we take on the world. So there are, are quantum computers faster? Okay, so let's try and answer this question, right? So it's a very important question because it will tell us, where is quantum technology going to fit in the coming years, right? So let's take a very simple operation, P into Q, when P and Q are large integers, and you want to multiply this number and find the number n, which is the result of multiplying P and Q. On a classical computer, on today's computers, the cost of this multiplication is 0.0025 seconds. Whereas on a quantum computer, the same operation is going to take you more than a minute. So fraction of a second on a classical computer and more than a minute on a quantum computer. So an operation, a simple operation like multiplication, is much faster on a classical computer. Okay, this has several implications, but let us see what is a quantum computer good at. Now let's take the opposite of this. You're given a large integer n and you want to factorize this into its prime factors p and q. So how do you factorize this large integer into p and q? If you were to do this on a classical computer today, this is going to take you 4.7 billion CPU years. Okay, and this is the basis for today's public key encryption systems. This is the basis for a lot of the communication that happens on the internet today. The talks that we give, the bank transactions, the encrypted data files that you have, all of this is based on this simple fact that a large integer cannot be factored on a classical computer easily. It can be done, but it'll take you billions of years to do it. But the same operation on a quantum computer will take you 8 hours. Okay, well, we don't have those quantum computers yet, but mathematically it has been shown that on a quantum computer the same operation will be exponentially faster. It will take you several hours less, several years less, several billion years less. So what did we see? We saw that multiplication is faster on a classical computer. Factorization is faster on a quantum computer. So what does that mean for today's world of computing? What that means is today's GPUs and CPUs, the high performance computers, the cloud, they're not going anywhere. They're going to stay here. The internet, it's going to change, but there are, the current form in which the GPUs, CPUs, all of them work, that's going to remain. The way you access things over the cloud, that's not going to change. What does the quantum bring? It brings this quantum processing unit, which is good for certain operations, right? Certain operations like factorization, which we just saw. So in future or even today, what is industry doing? It is, it's trying to build these hybrid workflows, which includes AI, cloud, blockchain, and bringing in quantum into it. Quantum is one piece there, which is going to speed up certain operations, but it's not changing everything, right? I mean, it's changing a lot of things. You're able to solve a lot of unsolvable problems, like you saw. Factorization today is unsolvable. But with quantum, you will be able to solve several unsolvable problems, and it fits in with the workflows that are currently there in the industry. And that's what today's industry is doing. It's trying to change how the business is conducted by using the enormous power that quantum computers bring. So I know this was also spoken a little bit earlier. So what is the fundamental unit of information on a quantum computer? It is the qubit. What does the qubit do? It is a quantum information bit, and it is the unit of information. Using these qubits, you build these quantum circuits. Okay, you build quantum circuits and you solve problems, right? That's how it is. And as the previous speaker had mentioned, qubits can be placed in superposition. What does that mean? You toss a coin, it can be both heads and tails while it's in the air. Only when you observe it, it becomes heads or tail. The same way, a quantum qubit can remain in this superposition state of 0 and 1 until you actually observe it. Similarly, qubits can be entangled. What does that mean? You and I are tossing two coins. By looking at my coin, I can say what you got, whether heads or tails. Okay, so I don't have to ask you anything. I can look at my coin and say what, so the two qubits can interact with each other. And this is where the power of quantum computing comes in. What does it do? Like a maze like this, a classical computer is going to look through every possible route on this on this maze. What does the quantum computer do? It puts the qubits in these superposition states, all possible outcomes. It puts them simultaneously and then eliminates out, what is not the correct state. And in that way, it is able to very, very quickly get you the answer. So what are the problems that quantum computers can solve, right? So this blue circle, this blue oval here is what today's classical computers do, right? So there are easy problems like multiplication, like this video conferencing, like my voice traveling over the internet to reach you, the quantum, the normal communications, our voice, video, image, all of that is easy problems today. What are the hard problems for classical computers? Things like factorization. We saw a classical computer can do it, but it will take it billions of years. So here is what quantum computers can do. This dark circle here, there are things that quantum computers make possible in a much, much faster way. Things like factorization, things like machine learning, optimization, materials, chemistry. And there are a class of problems that quantum computers can do, which no classical computer will ever be able to do. What are those class of problems? Things like, simulating molecules, observing how molecules interact to make drugs, to make fertilizers, to make new materials, to make energy, to make new batteries. All of those kind of simulations are quantum mechanical phenomena. As a result, you can never do it on a classical computer, but on a quantum computer, which follows the same quantum mechanical phenomena, you can easily do these things. So here is so what does the quantum computer make possible? It makes it possible to solve some of the unsolvable problems today, and it also offers an opportunity to solve some of the very, very new class of problems which will never be solved on a classical computer. So now, what is the maturity level of these quantum computers today, right? So 1944, that's our, diode-based classical computers. Today's quantum computers, you can compare them at that level. That's where they are, where the classical computer was in the 40s and 50s and 60s. That's where the quantum computers are today, okay? But the exciting thing is that it's moving very, very fast. We've learned a lot of things in these 70, 80 years since classical computers have been around. So 1981 to 2016 was the experimental phase of quantum computers. 2016, IBM made the first quantum computers available over the cloud for actual computation. This is the year 2022. We are in the noisy intermediate state quantum. Okay, what does that mean? We have quantum computers, but they are noisy. Okay, so they have a level of noise in them. How long is this going to continue? We don't know yet. It's going to continue a few years, a few decades. It's up for guesses, but a lot of people think that, this decade we are going to make a lot of advances. Okay, so, and that's where a lot of the research is going on. Fault tolerance is what we are aiming for, right? When we reach there, quantum computers will be able to solve all the problems that we are promising today. So how is the industry reacting, right? So this is a disruptive technology, and the industry is mobilizing resources to, figure out how can, we use this new technology that's coming up, right? So whether it is in agriculture, whether it is in airports, logistics, manufacturing, energy, pharma industry, each of those industries has started looking at, how can we take these quantum computers and achieve that advantage, that, that exponential speed up on a class of problems. How can we reach there, right? So there are several, potential use cases, things like, in finance, there are multiple use cases, including several where, for example, RBI comes out with a policy, but before it comes out with the policy, it is possible with the power of a quantum computer to actually try and simulate what will be the effects on the economy, on the inflation rate, on the savings, on how the people are going to spend, all of those things, it's possible to simulate some of those things. In chemistry, materials, life sciences, new battery materials, improving nitrogen fixation. Do you know that fertilizer making is one of the most polluting industries today? We need it for our food production, but producing fertilizers is one of the most polluting industries today. So how can you improve that nitrogen fixation process? How can you discover better fertilizers without polluting the environment? Logistics, optimization. So there are multiple use cases that people have started exploring. In fact, in logistics, one of the first RFPs came out from New South Wales, transportation department. They want to, in the next 5 years, see how they can completely overhaul their, transportation system using quantum computing. So there are several examples. IBM, along with Daimler, has been looking at how to advance battery technologies, how to, build better batteries that can last longer, shorter charging time, where you can drive your car longer. With ExxonMobil, we've been looking at, how can you look at various things, like thermodynamic observables, how can you, simulate chemical reactions. Similarly, with JP Morgan Chase, we've been looking at how can you, simulate or, expected value of the treasury bills, or optimize portfolios. Or like I said, RBI might want to simulate how, some of its policies are going to affect the country. So all of these are very important problems that the industry has started looking at. And now, how is the academia responding to this, right? So what are we seeing? A lot of the software today on quantum computers is open source. Okay, so Qiskit, one of the most widely used softwares for quantum computing, is open source from IBM, and people today are actually using this to program quantum computers, right? It's open source, people are contributing to it, people are using it, and collaborating to improve it further. So there is an open source textbook. It's very easy today for anybody to go out there and start learning, how to use quantum computers and actually start programming these quantum computers. And there are several courses, right? So there was one recently that IBM, my team, along with IIT Madras, offered on NPTEL. There were over 10,000 registrations. ISC started a new quantum technology program, just 20 plus seats, 1,000 plus applications. IIT Madras has a program running. I saw recently that BIMTech, one of the first one, the manager program that I'm seeing for policymakers and managers. So a lot of educational institutions have now come in and they've started offering these courses, both for free, paid courses, all kinds of courses are out there, right? And there are several, technology centers which are getting set up. So I'll not go into this. I know, Professor Vijay Raghavan also talked about this, and I think he'll talk about this later in some of the sessions. So I'll not go to that, but an ecosystem is getting built, right? An ecosystem which comprises of these startups, government, industry, university, application developers who are very excited. I get so many LinkedIn messages every day asking me, how can I start contributing, or how can I start learning? How can I find jobs in this industry? So a lot of people are getting very, very excited, and that showed in that NPTEL course, right? 10,000 plus registrants, and that website was open only for a few days. When IBM holds these programs for summer programs, some of the largest number of registrations happen from India, right? So there is a lot of excitement in India to learn this technology. So how is this technology developing, right? So what is the roadmap? What is the maturity? Quantum, this year IBM released the first 100 plus qubit quantum computer, 127 qubits. end of last year, 2021. This year, 400 plus. By 2023, IBM is going to be releasing the 1000 plus qubit quantum computer, right? And that's sort of the turning point. That's where, the inflection we are likely to see. You're going to start seeing, real applications on quantum computers, which are going to outperform what the classical computers need, right? So there is a measure called quantum volume. What is quantum volume? It is a measure that comprises of how many qubits are there. As I told you, it's increasing. The number of qubits are increasing, and the error rate. How many of these qubits fall into error when you're computing? So now, if you increase the qubits without reducing the error rate, that's of no use, because the quantum computer is useless. It still cannot, perform error-free computation. So you want to increase both the error rate and the qubits, and that's called the quantum volume. Moore's law, which we all know about, every 2 years, classical computer technology doubles in its performance. Quantum volume, which is the new Moore's law, doubling every year. Okay, every year the quantum volume has been doubling. Okay, and that's very promising. That means that in the near future we are likely to see advances using quantum, and that's why that excitement. That's why industry is adopting. That's why the government is in this, and that's why developers want to take up this technology and learn these skills. So I'm going to, quickly go into the way forward, right? So India became a software nation. We did that. We are a strong software nation. We all know that, but we missed making impact in hardware, whether it was in computing, whether it was telecom, or any other deep technology. I know the government is taking a lot of steps now to correct that. Okay, but what can we do in quantum? Right? Because this quantum offers us a clean slate now. We can do whatever we want. It's a new technology. We can become a software and a hardware nation now going forward, right? So as I said, quantum covers a lot of technologies: cryptography, computing, sensing, communications, and hardware. And in each of these, there is now an opportunity for India, which missed in the classical computing bus. We missed everything but the computing aspect or the software aspect. All the others, we did some things, but we are not a leading power. Okay, we are not a world-beating power today. And that's why the government has announced the national mission. Other speakers are talking about it. I'll not talk. But what is important for us to note is that 2024 will be the #1 software developer nation in the world, overtaking the US. 2024 will be the largest software developer nation. We'll have the largest number of software developers. Where did this journey begin? This journey began in TIFR when we built the first classical computers there. This journey began in IIT Kanpur, which installed the first classical computer in 1963. It had to be taken on a bullock cart to IIT Kanpur from the airport because the roads were bad. They didn't want to shake it much. But a lot of that journey can be the success that we achieved can be attributed to the professors in IIT Kanpur who, other IITs, I'm not saying, the others did not participate. They did. But I'm just giving you one story here, right? Which is that IIT Kanpur, there were professors, Rajaraman, Mahabala, they designed courses, they taught theory and programming. When I did my engineering in the 80s and 90s, I used their textbooks. I read from their Fortran from their textbook, right? And they started, these programming courses. They started the MTech program. For example, Narayan Murthy was from the second MTech batch of IIT Kanpur, right? Similarly, FC Kohli, he got TCS. TCS came up in '69, but before that, Tata Power and the others, they got trained at IIT Kanpur and on how to use these computers to do programming and how they can use it in that industry, right? And that laid a seed. And probably we didn't do that in the hardware, we did it in the software, but we need to do that in with quantum. And I really like what the National Quantum Mission is doing. It's focusing on the software, hardware, communications, all the different aspects, right? Uh, but unlike, there is a big difference between 1963, when the first when the first classical computers were installed in IIT Kanpur, and today, and that is that today you can access quantum computers on your fingertips using your laptops. You can run them from wherever you are. You don't need to go anywhere. You don't need that bullock cart to take your computer anywhere. You have it in front of you. There are several free courses, paid courses, and several, there is a large open source community that you can leverage today. So with that, I'm going to stop. So Gartner surveys have shown that many businesses are now adopting quantum. Several people have said that quantum skills are going to be needed, and several countries, like the US, has said that we are not going to be able to produce enough skilled quantum engineers. So what should be our strategy to get them from India, from Europe? And we should make sure today, of course, that we should skill our youngsters, but also the fact that we should give them an opportunity to use that technology skills in India to further our goals to build a quantum economy in India. It took us 2024, 1963 to 2024, 70 years to get to this level. But with quantum, we should not take that many years. We have to do it much, much faster. We have to take that leadership position much faster. And as Nobel laureate Bill Phillips said, using quantum principles to compute is as different from classical computing as classical supercomputer is different from abacus. It's a new technology. It involves learning new skills. So we need to skill, we need to get our workforce ready. So thank you very much.
Uh, Thank you. Thank you, Mr. Venkataji, for sharing your view and presenting such a complex subject in a very simplified way. He is extensively working in quantum technology and application in government sector. He is having around 25 years experience in government sector. His contribution is immense in shaping the government policy on quantum technology. Sir, we are very eager to hear from you on the policy and various initiatives taken by the government of India. Sir, now stage is hand over to you. Please share your view.
Uh, Good morning to everyone. Thanks, Dr. Garg, for giving me this opportunity. I would like to concentrate on what are the government initiatives, particularly Department of Science and Technology, for the last 3-4 years in quantum related areas, and how the things are shaping up within the government, so that we can foster the upcoming field of quantum technologies. Well, as I was listening to Dr. Venkat, about the entire spectrum of how the quantum technologies are evolving, what is the position in India and what is the position in abroad, and how a new opportunity is emerging for us, to re upon the benefits of these quantum technologies. He has nicely summarized it. I will be dwelling upon some of these points, where he ended, and I will be starting on what exactly the government is doing. Well, before getting into the what Government of India, particularly Department of Science and Technology, is doing, I would like to share my thoughts on where the digital technologies has ended or going to end, and what are the new opportunities. Well, if you look at the total spectrum of the classical computing or digital technologies, probably started with the Alan Turing mission during the World War, where Enigma was resolved, and that ended what you call World War II. Rather, it is a technology which ended the World War II. That's what the people say. But again, that was a great invention at that time. If you look at the next generation of technologies like ENIAC and the vacuum tubes, then comes the digital circuits, and finally we are now in the current technology in the digital classical computing. But if you look at the entire the developmental cycle of these digital technologies, probably we were nowhere. We entered directly into the PC world and get the grip on the software side. That's what exactly Dr. Venkata told. That is correct. Because we are not in the earlier generation of development of digital technologies, probably we missed that entire buzz, both in terms of the processor development or operating systems or network products or network protocols or standards development, and somehow we picked up in the software side. We have done a very fantastic job. So there is a innovation that happened in the software cycle, and we're able to match our skills with that particular gap, and we're able to fill it up. That's where the our position as per the classical systems are concerned. Now, why people are moving towards the quantum computing? There's a big question. I used to ask myself, when there is a supercomputers, which is the fastest computers on this earth, and we have digital communication, satellite communications, and the sensors are there. Classical system based sensors are available. Good algorithms are possible, and we are able to solve most of our the problems now, either with the climate change or molecule development, or those things are happening within the classical domain. Now, in that case, why world is concentrating so much on these quantum technologies? That's a big question I used to ask myself. What I gathered is, in classical systems, of course, these what you call the limitation of the speed of light is coming into foray. We are not able to break in that particular barrier as of now. I don't think it is possible also. That is number one. Number two, the application complexity is increasing. The more power is required in computation, secured communication, or very high unprecedented type of accuracies in sensing. And also, we are also have to have the type of materials which can cater to these needs. That is quantum materials or 2D materials people talk about. Those are all required to realize the type of requirements in the terms of qubit or sensitivities and things like that in the quantum field. So entire thing is coming up as a challenge for us now. Now, when we have that type of requirements, the classical systems has the limitation. Therefore, we need to foster on to the new emerging technologies. That way, if you compare with the worldwide developments, India may be at the level of 3-4 in the in the scale of 10, but we have the capacity and the capabilities to scale up our activities, and probably we can be one of those the front runners of those technologies. So the opportunities are available. There is a challenge and there is a opportunities. So how to convert this opportunity? That is something which we need to evolve our own strategies. That's what exactly the Government of India and the DST is planning to do in association with the PSA and other department, other stalwarts in the field. Now, what exactly we are doing? One is why it is required. That was so many speakers talked about it, and people also talked about the opportunity. If you convert that up, you want to convert that opportunity into tangible technologies for meeting our requirements and as well as economic growth, then what exactly we are doing? That's a very important question. Yeah. So, Department of Science and Technology. Yeah. Yeah. There is somebody. Can I proceed?
Yes, please.
Yeah, there is some noise coming. Okay, thank you. So, If you look at this quantum technology, as rightly told, we may be there in the at the stage of what you call the Alan Turing mission level. Still, in the terms of computing, in terms of communication also, we are at the better than the computing. In the sensing, we are all still far better than the communication. Therefore, there are certain technologies which we can quickly convert into products. For example, in the sensing, in the communication, maybe after some time, maybe the computing. When you talk about computing, it is not a general purpose computing which you're talking about. There is no, as of now, demonstrable general purpose quantum computing as of now. We are all talking about very specific applications and very specific algorithms which the either quantum computing computer or quantum computer simulated in a digital environment. These things can do. Okay, so there are certain initiatives that Government of India has taken. Particularly, I will talk about the three initiatives which we are at what DST is working on. Because it is a research driven. Fundamentally, it is a research, and then it gets into the translation, and then gets into the deployment. In the domain of research, we have DST has initiated one R&D program called Quantum Enabled Science and Technology. That was started maybe 2 years back. We identified, the researchers, very young researchers across the country, and there are around 50 people who has a very good background and associated with the stalwarts in the worldwide universities and research organizations. They came back and took up the position in Indian research and academic organizations. So that Quest program is the first R&D program initiated by DST, and it is for the 3 years. And whatever the process and procedures are, the methodologies that worldwide people are adopting, more or less all the methodologies are available within the Quest program. Because we don't know which process or which approach is going to realize the required the technologies. Therefore, we have picked up all the pathways, either in terms of superconducting qubits and ion traps or NMR, and as well as ion traps. These are the various approaches worldwide people are taking up and then pursuing it. Okay, so we have created 4 clusters, and each cluster is having around 20-25 researchers, and then they have been properly and sufficiently funded to take up this research, and they are very eagerly working on this. So here, the Quest program, though it is fundamentally concentrating on the R&D, it also has got the human resources development component also. Because if you look at the number of researchers in the quantum domain in India, relatively it is very limited actually. Therefore, our first challenge is how to increase the base of researchers in quantum field within India. So that was one of the secondary goal of this Quest program. So therefore, there are some 100 PhD scholars they are associated with this. There are 100 researchers, both in terms of project investigators and co-investigators and the other scientists in terms of postdocs and other people. So a total of around 250 to 300 people are associated, directly, indirectly related to the quantum field in the Quest program. So that Quest program has started 1.5 years back, and it is progressing very well, and we expect good results out of it. Once we have this R&D, we also need to talk about the translating that research into your products, because that's where the main challenges comes into picture. Because academic parlance, translating a research into a product is still has to evolve within the country. We don't have that type of associations with industry. Therefore, mostly we end up either in terms of publications and or as a PhD or things like that, the academic intellectual activity that is required, and that is where we end up normally. But there are cases where they're able to take it to the translation also. But in quantum field, we require that kind of a translation platform where this R&D is taken to a product level. So for this purpose, there is another initiative called an innovation hub at Indian Institute of Science and Education Research at Pune. So that innovation hub was created 2019 with a good support of around 170 crores. The fundamental aim and purpose of this particular innovation hub is whatever the research or the pathways or the innovation that happens in the Quest program, take it to a translatable translation and try to develop a product which can be deployable for our requirements and as well as for converting into a economic value. So when you talk about this innovation hub, the three helix, normally we talk about in the government parlance how to bring the three helix. The three helix are academic, industry, and government. Okay, so though we talk about elaborately about industry collaborations, unless otherwise they see a value in their investment, the private industry looks at the return of investments. Unless otherwise they see a value in their investments into this type of platforms, normally they don't come in forward. Otherwise, normally the CSR grant type of things, it is a very loosely coupled things. But here we require a co-development, co-partnering, and co-sharing of revenues. That is, in a structural way, it has to be arranged at the platform, and then therefore the three helix can come together and benefit, the each segment, so that there is a mutual benefit for everyone who is participating in that. So that way, this innovation hub was created as a Section 8 company, not for profit, and with a mandate that rapidly they have to have a collaboration with industry and with the governmental, the problem statements coming from the government and academic, community to working in the researchers. Okay, so once we have that platform created, already we have created it and it is working, but industry collaboration is minimal at this stage. Maybe we may have to foster, for them to encourage them to come and participate in this particular platform, so that quickly we are able to garner the benefits that is coming out of this research that is happening in the Quest. So number one is Quest R&D, and number two is Innovation Hub, that is the translation platform. That was number two. And the third thing is Government of India has announced in its budget in 2020 that there is a requirement of a national mission on quantum technologies and applications. That was announced in the budget. Other speakers also mentioned about it. And that again, as a DST as an agency to coordinate with other various stakeholding ministries, including DOT, MIT, DRDO, space, atomic energy, and PSA guidance. Anyway, it is there with these activities. So it is a multi-institutional, multi-departmental activity mission, and that's how the entire strategy, the design of the mission is done. So this mission is under processing, and probably it will be coming up to forefront maybe another 2-3 months if everything goes well. And the purpose of this particular mission is the scale up, the quantum research, translation, and deployment activities at the highest level. Quite a good sum has been, announced in the budget, and government is keen on, implementing this particular mission. And the model, probably it will be a scaled up model, what we talked about, Innovation Hub at IISER Pune. That particular model will be taken up at a very higher level scaled up model, so that all the, the participants of, this particular technology development will be, given opportunity opportunity. So this mission is in advanced stage. As I told, maybe another 2-3 months, it may come for implementations. And it has got, the components like, the technology development, the startup ecosystems development, human resources development, and of course, the international collaborations also. As I told, it is purely driven by research at the initial stages, and then it has to go for translation. So it is a huge mission. At least the best of my knowledge in SNT, spectra, we can reckon it is one of the biggest mission. Apart from space and atomic energy, they have a bigger mission than this. But in open science and research, this is the biggest mission. So that shows, the interest of the government, that how to foster, the upcoming technologies and how to garner the benefits that is going to come out, from this, R&D. So that is SNT-led economic development is one of the, core pillars of this particular mission. So here there are certain, impediments or challenges that we are facing in terms of, the innovation hub at ISER Pune, or maybe it may come up, in the mission implementations also. That is the industry participation. Not much as of been shown as of now. People are just keenly observing and estimating or testing the waters. Let me take an opportunity to tell that we are very open in collaborating with the industry as a co-developer, as a co-investor, and a co-sharing of revenues. The IPs are very clearly mentioned in the Innovation Hub. The IP revenue sharing is also more or less we have written, and the international collaboration is also one thing that both at academic and as well as industry level, we are looking forward. Also, the as of now, not much of interest or participation is seen, but I am very optimistic that in coming months we will have their interest and then their participation, and also the startup ecosystem, which is very pivotal in the entire innovation hub, that also needs to be encouraged. And come to the startup ecosystem. Not only this particular hub, we have another 25 number of hubs created in all other digital technologies, not specific to the quantum, but this particular hub is on quantum. So when you talk about the startups, both in terms of the investments, either in terms of the venture capital, VC capital, or the creation of a fund of fund, and also we can look forward for attracting FDIs also into this particular hub. So there is a separate structure created to attract the FDIs under the guidelines of SEBI, and that structure is also coming up very soon. So therefore, there is a multiple channels of the both in terms of investment and technology, and as well as the commercialization. All opportunities are available. When you look at the number of startups, we are open for providing equity and the listing also in the exchanges, and there is a SEBI guidelines very clearly mentioned about the incoming into the startups, and then even for exit also. So those things, those structural changes are in place in the innovation hub. So I take this opportunity to convey my sincere regards to all the participants, and as well as particularly to the industry. Please come forward, guide us, be a partner of this particular initiative, and as in terms of the co-investor, co-developer, and a co-partner in developing this technology, and as well as sharing of revenues that is going to come out of this. So it's a very good opportunity for every one of us, to the researchers are very encouraged. They are our youngsters. They want to contribute to the development of these particular technologies. The government is also very keen. That means the academics are ready, the government is ready, is the industry ready? That is the question. So please look these particular aspects and then come forward for participation. And very soon we will be going to listen about the mission, and probably the PSA sir will talk about more on this. And as of now, we expect another 2-3 months we will hear a good news about this particular mission. And I thank the organizers for giving me this opportunity to share some of the thoughts, and I thank everyone for listening. Thank you. Over to Garg.
Thank you, Dr. Muliji, for sharing various initiatives and policy of the Government of India on quantum technology and application.
Good afternoon, everyone. I hope my screen is visible.
Uh, yes, Mr. Patel, your screen is visible, but can you enlarge it? Your PPT.
Better? Yeah, you can see that now, enlarged.
Yes, we can see.
So good afternoon, everyone, and thanks, Mr. Garg, for giving me this opportunity. I feel really honored to be part of this exemplary panel on quantum. Just a brief background: I've been a lifelong 3 decades plus evangelist, and I cherish the opportunity to provide guiding light in disruptive technologies since the last 3 decades in India. Starting with my first was in the mid-90s in high-tech city Hyderabad. I started the first company there in the cyber towers, to bringing solar PV in 2009-10 in Gujarat, and I was one of the 20 companies to do the first 10 megawatt photovoltaic plant there. Next, I was working with Professor Desai, IIT Hyderabad. We created the first BTech in artificial intelligence in India, third in the world. And currently, I'm last 4 years working on this quantum communications company called Qulabs. And towards that, in 2018, I contributed with Dr. Chadda of TCS to make the first quantum computing standard contribution from India for the ISO. So Qulabs, I'll quickly breeze through what we do, and then I want to come to the core problem of startups. So we are kind of positioning ourselves as leading the world in quantum communications. So most of the speakers kind of give a brief of glimpse of why. So it's because the future is the power of 3 particular things: superposition, entanglement, and teleportation. And it is secure, unlike classical communication. It is blind, unlike classical communication, which can only be to a certain extent with its homomorphic version, which is very costly and almost unimplemented. And this, because of the entanglement, it drives super efficiency and ultra security. So why we focus? I was involved with the quantum for the last 5 years, and initially, as anybody else, having gone through the MIT certification for a year, I thought I would do something in quantum computing. But then I quickly realized that the West, IBMs of the world, and the companies in Canada and Europe were way ahead. And focusing, my interest was to, as usual, one of my 8th startup, to focus on how to do something in India. And I realized quickly that I had to pivot into quantum communication. So we know that commercial problems that need to scale, as Mr. Venkata also covered in one of his things, is where this will be very useful. We are limited by time and power, because as also some speakers brought out, that the power consumption exponentially increases. So quantum kind of resolves some of those issues. And then obviously the complexity, and finally security. Right? So these are the things. And as any startup, as any person, eventually they want to see something monetizable, something to show that if they go through certain coursework or research, it has to be translational research, right? That's what we are focused on. So this is a large opportunity. This is a number out of 2018. This has grown exponentially since then, the old number. And so who we are quickly accelerating quantum communications in various aspects through multidisciplinary focus, as Professor Murli, Mohan, and few others said, through strategic tie-ups with various institutes, global institutes. First, it was Indian institutes like the IIT Kharagpur, IIT Roorkee, IIT Madras, and IIT Hyderabad, and ISI. And now we are tying up global institutes like the Bristol University, Keio University, to bring to our folds so that we could build the next version of communications in India. And so what is the value generation model, right? You build the ecosystem through research labs, through networking with scientists. We are about 10 very well-known Indian scientists working with us as advisors and consultants. We generate IPs, productizing these IPs, and the labs and industry collaborate. That's we are the industry, and then we bring more industries with us. And then finally, there has to be an exit value, right? So there are different techniques. This is a general quantum value chain for those other students and people who are new and uninitiated in this. So this is the mother of blocks, the components, the quantum systems, the quantum hardware, communication device, a whole bunch of them, and the various domains. And why I bring it to show you where we play. So among this whole thing, these are the places where a quantum communication device, quantum memory, network, blah, blah, blah. So we are trying to solve global problems through translational research. So creating secure, long-distance, scalable internet. Towards that, we have 4 patents already, and 6 are in the pipeline. Applying quantum machine learning to some of the techniques to enhance some of these protocols. Creating highly secure communication through quantum memory repeaters, and thereby set up communication which can be also used for distributed quantum computing. So this is the ecosystem which most of the senior folks in the panels have said. We are trying to work with government consortiums, MIT, DST. In fact, the QSIM that get mentioned all over India was actually, ideated by us with Dr. V.K. Murthy, and then we took it to ISC, and CDAC was involved, and it was primarily driven through our IIT Roorkee lab. But besides that, we have the first quantum network simulator, which we got an award by IonQ, the first company that went public in US a couple of months back, trading at over 6 billion valuation. We have first blind quantum computing simulator, and a whole bunch of novelties we have created. We partnered with IBM, AWS, Microsoft, and also 2 years ago, I kind of drove a strategy in Telangana government to set up something called Quantum Valley, which would bring some of these big players there. And we had 2 government orders passed, but because of this COVID, I think things have slowed down. And with academic collaboration, both locally and internationally. Our idea is, as Professor Murli Mohan rightly said, to have research partners, create world-class labs, create a lot of quantum scientists. We have about 28 now, build IPs, create products, and then create value. So that's the way we want to go. These are our multiple IP developments. You see that some of these have patent numbers, 1, 2, 3, 4. Another one just is coming this week. There are 2 others in the quantum memory, where I think only other company called QNet has showcased a real quantum memory between Brookhaven Labs and Stony Brook University here, and they're getting some 400 nanosecond worth of storage. And with our current models and our simulations, we are getting more than that. That is through the thin film and few other techniques. And a whole bunch of other IPs. We have planned to do at least 15 to 20 this year. And these are some of our ongoing efforts. This is for a whole bunch of students who are on the webinar today. That we on an average we have about 30 to 40 interns from IITs, NITs, other regional colleges. We support in the last 3 years. We must have supported more than 150 interns, from BTechs, PhDs, postdocs. So these are some of the areas: quantum memory, quantum AI, blind quantum, post-quantum crypto. So a whole bunch of things that relate to quantum communication is what we work in. And our idea usually is we start with a small team. We survey everything from, the earliest thing that happened to what's happening now. Then we discover and focus on things which can be translated into some real products. And what's the need for India, right? In my last 4 years journey, talking to DST and Mehti and Professor Ashutosh and Professor Swani and a whole bunch of people, Dr. Murli Mohan, I met a couple of times, and a whole bunch of ISER, IIT people. There seems to be it used to be a problem in 19 and 20, which we didn't have quantum optics lab. A lot of our PhDs and postdocs went away. Now we are setting up first quantum optics lab, which will help us retain some of these very high-end resources, right? So, and some of these IPs that we have built in quantum memory and quantum network routing protocol and few other things, blind quantum, can be actually showcased in actual hardware implementation. So we have currently grants from IMQ and AWS through MIT, which we have access to the actual quantum computers hardware on the cloud, and we are trying to implement that. But India as a country needs to have its own infrastructures which will foster other startups and other companies to join. Right? So that's that. So this is like a holistic and collaborative. The last slide, I want to focus on this. So we need to set up a high quality quantum labs. You need to set up, and obviously some of them are being done with ISER Pune, but somehow that is not translated into as Professor Murli Mohan, Dr. Murli Mohan said, that the industry is not reaching out. Obviously, there are some gaps, and we need to see how to close that. We need to see, currently we are facing that high import duty of scientific equipment, right? And we try to build our own through Thor Labs and other foreign companies to bring our own equipment that we need for setting up the lab. And there should be some provision, just like in the solar in 12 years ago, they provided provisions for import duty kind of something to aid to the startups and other companies. I think this will go a long way in building the ecosystem in India, especially on the hardware side. And obviously collaborating with universities, labs, industry should come. I think there should be a centralized hub which should give access to different universities rather than fragmenting these resources across 30, 40, 50 efforts. There could be zonal 4 or 5 or 7 or 8, very like how it happens in US. I'm part of Quantum Economic Development Consortium here in US, and what they do is there are 4 hubs, one in Chicago, one in Maryland, one in Arizona, one in Southeast. And that kind of gets a lot of things in one place, and that's how they're kind of making progress, right? And for funding of new startups, right? Currently, obviously, like any other company, it's all bootstrapped, and I'm also looking for funding. And obviously, this is a very nascent thing for a lot of venture capitals, but I think there's a need for having a quantum fund in India or for India. And I think somehow the government or other people or investors, VCs have to come together to provide that, so that I get like almost 30, 40 interns, and some of the IPs that we have built have ideas that have been driven by them. So I'm sure if we given them an opportunity, a whole bunch of these young kids would come up with really groundbreaking companies. So that's where I think I end. This is our thing. Thanks a lot, and I'll wait for Q&A. Thank you, Mr. Garg.
Yeah. Thank you.
I kept it to 10 minutes, under 10 minutes. So
No problem. I understand. Thank you, Mr. Patel, for sharing your view regarding the quantum technologies and various initiative taken by your company. Now, I would like to invite Dr. Nagendra ji for sharing his view. Please, Nagendra ji.
Yeah, thanks, Mr. Jitendra. Thanks for Department of Telecommunication for organizing this wonderful thing. I'm just going to share my screen now. Okay. So, can you see my screen?
We are able to see.
yes, we can.
Okay, so today I'm just I'm very honored to be present here and with prestigious co-speakers who are really qualified. Thanks a lot. Today I'm going to present QIPAI Technology. QIPAI Technology is a conglomerate of quantum companies where we are marrying the quantum with a lot of other application. There was one say by technologies that technology hunts in pair. So we have implemented that in live. So the motto of QIPAI Technology is to provide, advanced technology to advance humanity with the technologies which is very advanced, serve humanity with advanced technologies. Okay, QIPAI Technology is a holding company, and we have 5 subsidiaries: QIPAI AI, QIPAI Cloud, and SuperQ, QIPAI Ulta, and QIPAI Semi. QIPAI AI is all about advancing AI and its application. It's software heavy, and we have one 3-chip solution for the hardware. QIPAI Cloud, we are building quantum data center. We are also building newer protocols and making sure that data centers work securely. QIPAI Cloud currently have data center management infrastructure, which competes with VMware. And we are developing the edge to cloud deployment, and we'll be developing something called as a new edge cloud computing technology called collaborative cloud computing in QIPAI Cloud. SuperQ is incubated in Sense Lab, and we have already 2 products. One is the single photon detector and single photon source, which is very very important for quantum network. This is all indigenously made in India. And other thing is SuperQ is also producing superconducting tape. Superconducting phenomena is a quantum phenomena, and we are the only company in India to make this superconducting tape, which goes into nuclear reactors, nuclear fusion. In fact, worldwide, all the fusion companies knows about that, knows about SuperQ. And we are setting a factory in Bangalore, in aerospace says, where we are manufacturing this. And QIPAI Volta is a battery company driven by quantum compute and AI. So what we're doing is we are modeling end-to-end battery that is going into the lot of these EVs and other application, because the field behavior of the battery is very critical to predict, and that can be done by quantum computer. And other ambitious things we have is it's called QIPAI Volta ET, which is energy transition software driven by quantum computer. And last but the most challenging one is we're trying to come up with the quantum batteries so that we can use quantum energy harvesting. It's a very early stage thing. There are only University of Toronto and some of this university have a proof of concept, but we want to implement it in real. And QIPAI Semi is fabricating semiconductor company where we are designing a quantum secure processor, and we are also actually working on AI 2.0, which is quantum based. So these are 5 companies. I'll just go quickly. So profile of QIPAI AI is 2019 it was formed. It's a profitable company. It's one of the profitable companies for quantum and AI, and we may list this company as soon as possible. And it has many products. Some of them is Pro, which will be based on quantum very soon. It's a auto ML plus ML of AI solution. We do require quantum computing for AI modeling. Current intelligence modeling and compute will change, and we are the leaders there, where we are going to actually put all the AI modeling on the quantum computer as soon as possible. Like especially search and other optimization technique which is required for AI modeling will be done very well by either quantum inspired solution or a quantum directly quantum solution. And we also have a classical chip, which is a universal optimizer chip. Here is a 3-chip solution. I'll go in detail into this. And the second thing is we are tied up with IISc for joint certification in AI and quantum. We have totally 20,000 registered user now. Okay, and we have just first batch is just passed out, and this should enable education in quantum computer and AI. So these 2 technologies always goes together. And we will also launch few new courses for executives and other people, and it's a very grand success for us with IISc. This course has taken off very well. And third product we have is in finance. We have a Standard Bank as one of our customers, and we have a full suite financial software based on quantum computer I'll be going through. And we have AI and quantum marketplace where we have shortage of skills, and this marketplace through certification should enable anybody gets distinction of the certification will get free access to the marketplace as a seller, and they can set up their own business. And the hardware part, we have a 3-chip solution. We have a fantastic team which have already done a lot of things in hardware, and we are building the protocol stack, the software stack for this hardware, which is very very robust. We're both supporting classical and quantum, which should allow seamless transition to our customer into quantum computing. So we'll have a classical chip, and then as we add number of qubits, currently we are planning, I'll show you the roadmap, we're planning around 20 qubits. And sooner or later, we will be at 1,000 qubits, both on spin qubits and on the superconductor base. And we are also expanding in Europe with the center in Europe. And pharma is last but not least. We have a lot of customer interest in pharma, and we have a very good software which we have demonstrated with few customers, and waiting to actually scale this. And this is about a QIPAI use cases. This will currently is on GPUs, but we are going to take it on to quantum computers soon. Okay, it will be going on our the classical optimizer chip, which is quantum inspired, and soon it will be supporting the quantum computer as well. And these all the use cases when it runs on classical plus quantum computer will be the best, and we can consume much less energy than GPUs today, which currently which is not sustainable in AI. GPU consumes a lot of power, and that is the market for us. And the second is the logistics. We have a good software in the logistics, route planning, supply chain optimization, warehouse inventory, and then task assignment, automotive factory optimization. We'll be scaling this solution also this year. We have a couple of customers who we are working with. ZF Group is one of them, and we'll be scaling this solution in a big way in 2022. The product is just complete. Now we'll be actually deploying this. And finance is the biggest market for quantum computer, and we have currently proven on portfolio optimization and credit risk profiling. So these two are proven, and we're working with SEB to actually on a POC, and after that we are going to scale with many other customers. So and pharma. So pharma, we have solutions for quantum simulation, force field, protein folding, drug similarity search. These are all again based on quantum inspired solution plus graph neural networks. And we are waiting for, actually it will be very fantastic if you have 1,000 qubit machine. This will be very powerful with 1,000 to 2,000 qubit machine. And we will slowly optimize the software, and when the hardware ready, we'll just turn on the switch with our prospective customers below. Okay. And quantum computing hardware is a big market, and we have all the customers waiting for quantum computing hardware. Okay, so and we'll be very glad to provide them one by one. First, with a classical quantum inspired solution, which is seamlessly the software will, once we have the qubits in the count, we just need to join our hardware, and it will be up. So our customers will have a seamless experience of increasing the performance without really changing much. This is a hardware where we have three chip solution: quantum control chip, quantum processor, and classical chip. The classical chip is a door for every quantum application, where it can determine whether it can be any optimization problem you throw at that. It will determine whether it is classical or quantum, and automatically route it to quantum computer as and when required. This is very powerful concept and our patented technology, where current application, once they are into this, they don't need to change anything. Okay, they just need to plug into our the stack, and everything will be running. And whenever the quantum optimization required, it will use a quantum optimization. So we are on to spin qubits. We are working with ISC to fabricate this year. Okay, so and we are also working on superconducting qubit also. Both the qubits we are working on, and we see advantage in the spin qubits. But the biggest breakthrough we'll be obtaining is the reduction of noise, and also the way we can use a interconnect from the chip, because there will be a lot of wires here once we scale this, and we're figuring out the way we can read from the chip. And other thing is physical to logical qubits mapping. Usually, like there may 100 physical qubits to one logical qubits is what we're looking for. And we are working on various surface codes and other techniques to make sure that our gate noise is reduced. And we are also working on certain fabrication technique with our partners in Europe and TSMC. So we also have a superconducting qubit. 20 qubits is what we are planning this year. And this year we should have both superconducting and spin qubits. And this is a roadmap what we have. So we should be, we're also setting up a big lab. We announced 1,000 crore investment in Gujarat Summit, and we are also setting up a factory in aerospace in Bangalore. Okay, it's a big factory where we have a manufacturing line, labs, and also some of these prototyping exercises. And this is for semiconductor process. Semiconductor, we are targeting around whatever qubit count we get. That's good, because in India there is no semiconductor qubits which is scalable. So we want to prove that first, and this is happening this year. All the things are happening this year. And what is the advantage of semiconductor qubits? There is already one Australian company which has shown that the noise is reduced to an extent that it can be used. It is very competitive to other qubits. And this is the advantage we have with our competitors: Google, Rigetti, IBM, and Psyquantum, and Q. If we can prove the scalability of spin qubits using semiconductors, I mean, that will be the way to go. We want to reduce a quantum computer which will be of 10 by 10 room size to a size of coffee machine if we can take it to a 4K operation. That's a critical research we are doing at QIPAI, and hopefully this year we'll have some noises and we'll make some breakthroughs there. And other companies, SuperQ, this is also very important. Quantum chip is not only the quantum phenomena, but superconductivity is in a big way. Okay, so this is the product we have. SuperSense is a single photon detector, and we have LTS cryo cables, and then we have 2G STS cable, which can be used in nuclear fusion. It can be used in multiple applications. We have motors coming up, and magnets. For example, nuclear fusion require a huge tokamak magnet, and that requires STS tapes, and that is where we have a lot of demand for these tapes. And we're going all the way, and we have collaborated with IIT Kharagpur for the cables. We're working with CPRI to give India's first superconducting cable, which is very, very important for energy transition. If energy problem is not solved through quantum phenomena, it will be really difficult for us to achieve any energy transition, because all this renewable energy requires a transmission, and that is where all the losses are. So we are covering that with the cable. And these are some of the application on single photon detectors and single photon source. I think we have a lot of collaboration possible among the companies which are here now. And this will be taped out this year, and it will be available as a sample. And we would be glad to provide it to a lot of other companies here. Okay. And these are key metrics what we have for a single photon source. And these are the other applications for single photon source and single photon detector. A huge application for this, and this will be first time that we are making this in India indigenously. Okay, and other applications are not small. For example, batteries is a huge thing, and we are making it here in India. We will have a gigafactory in India that is being set up, and then that uses the quantum and AI to design the technology to design the batteries. And long shot that we will try to get this quantum battery to some shape. Okay, so that if that happens, that will be real breakthrough innovation for us. And then QIPAI Semi is we are designing quantum secure CPUs for data center, and we have huge tracks there, and also cryogenic applications for space. So these are two things that's happening in QIPAI. So these are team, very qualified team. We have most number of PhDs in the country for quantum computer here. This is a 40 people team, and we have very stellar advisory role. We're adding, we'll be announcing soon QIPAI Finland, and that should bring us two more names in quantum computer on the board. Yeah, so thanks a lot, and I'll be very glad for question and answer.
Yeah, please. Thank you, Mr. Nagendra ji. So now I would like to invite the last speaker of the today's session, Mr. Sunil. Sunil ji, please take the stage.
Yeah, if you give me access, share screen. Okay. Can you see my screen?
Now it is okay.
Can you see my screen, please?
Yes, we are able to see.
Okay, good afternoon, everyone. So I'm the last speaker, but I'm going to take you down through a very interesting journey from thoughts and ideas to reality. Okay, so we are talking about Qulabs, which is a front runner in global safe security products. When I talk about it, I'm talking about Dr. Murli Mohan talked about it. Industry need to come forward. IBM ambassador Venkata Subramaniam said that India shouldn't miss the bus. India has not missed the bus. Qulabs has put India on the quantum map of the world. We are the first company in India to have built this technology, incubated in IIT Madras. We have tested standardized product that are competing with best in the world. In fact, we have the product which is even competing with even the best of the world, even like Toshibas and ID Quantics of the world. So completely production ready, commercially deployed in India and abroad. Several patents, one guaranteed, and several filed. Several trade secrets which we want to keep with us right now. 50 people team, all with optoelectronics, computer science, mathematics, quantum physics. It's going to be 100 in next 6 months. So we invite interns to come and join and not work only the IP, but really work on the products. Really see. And the interesting part is some of our young guys who joined us, within 1 year of their career, they actually filed patents, right? And they saw that those patents working in the commercial product. We got all the awards that possible: NASCOM, Emerge 50, League of 10, DSI, Most Innovative Award of the Year. We were very fortunate to have got a built good ecosystem support. We were nurtured by Cisco Launchpad, Intel Startup, NASCOM, Deep Tech, NetApp, all top product companies. We were funded by DST, Dr. Murli, Mohan. Thank you very much. The TDB funded us to commercialize our product. And CS funded us, IDEX. We were the IDEX, that is the Innovation Defense Challenge too. We were one of the winners there, where we are taking India to in front of all the global companies in terms of the technology that we're building. I will talk about it a little later. We're also funded by some of the private VCs and investors, the guys who really believed in the team and believed in the mission. And then we are also supported by Army Design Bureau and other government organization to make sure that we get to the right visibility, to the right audiences and the buyers, so that we can demonstrate our technology not on slides but actually on the ground. In terms of accomplishment, we have the India's first quantum random number generator product, quantum key distribution, and as one of the first speaker talked about it, we have taken QKD from point to point to actually networks of QKD. So today, India can build a quantum networks, point to multi-point, and our whole idea is to build network of networks, right? We have also done some of the stuff like taking some of the applications, whether it is video conferences, messaging, and I'm going to talk about that a little later. So what the world is worried about? World is worried, if you see, the trust is going away. One side, the world is moving towards hyper-connected digital world, AI, quantum computing, IoT, 5G, all technologies converging at the same time. But everybody is talking about zero trust. Because the problem is that cybersecurity, the way everybody has done is by building the layers and layers, assuming that the other person is a wrong person, and what has led that to is inappropriate solution, inefficient solutions, and deteriorated customer experience. What the world needs is not zero trust, but a quantum trust. Quantum Q-Day is when the quantum computers will arrive. IBM is anyway, we are looking forward to 1,000 qubit quantum computer. This morning, we got a news that Chinese scientists have almost about to break RSA 2048, right? And then we are talking about Web 3.0, where today, you know that, right? Internet was not designed for security, mobile phone was not designed for security, but our whole world revolves around it. Now we're still okay because banks, healthcare, hospitals, institutes, they were the owner of, or we call it centralized trust. They were the owner of the trust, owner of the key, owner of the encryption, and so on. But we are talking about Web 3.0 now, where it is blockchain based. All the trust is going to be centralized. At the end of the day, it will be IP address and the key, private key. Who is going to protect that, right? And that is the world we are talking about. Here comes QNU. So what we need is secure communications. We look forward. We expected this world to come probably 2 years down the line, but it happened sooner than we expected. That is exactly the vision the founders had of Qulabs in 2016 when we incubated this company in IIT Madras. So what we need, what the world needs, source of true randomness. True randomness is actually a very difficult phenomenon to do. You can't achieve that until unless you use the inherent property of quantum physics, right? So that you generate keys and one-time passwords, which cannot be guessed, and there's no correlation between the keys and the numbers. Second thing, you need to make sure that you are be able to authenticate everybody who's coming to the system. You mean the digital certificates and everything else that you build should be secure. Now, what has happened? People are building second layer authentication, third factor authentication, because they do not have the technology to do a right authentication. Third one is you build a key, but then you want to make sure that key is not public key, because with quantum computers coming in, if you use public key, PKI, then somebody is going to harvest that key and then break. So world needs a quantum symmetric key, quantum secured, which can be used end to end, whether it's a messaging application, whether it's a video conference application or a 5G network, right? We got that all that done 2 years ago, and then we have these products. Tropos, India's foremost, one of the best random number generator. Our random number generator has been compared with some of the best top 5 companies in the world, and some of our customers has chosen our product over even the top companies, so-called top companies in the world. Quantum key distribution, we have 150 kilometer single hop QKD today. With trusted node technology, we have broken the distance barrier. We can build any network for 1,000, 2,000 kilometers doing this. If there is no optical fiber, dark fiber, we use post-quantum cryptography, which is also available today. we're building a hybrid networks, we are building, so as we speak, we are building a point-to-point networks, star networks for India. So India, sir, is far ahead of everybody else, even far ahead of Israel today, far ahead of even US today in this particular deployment. In terms of some of the data use cases, you can actually do a near-site data disaster recovery, 2 data centers, maybe 1,000 kilometers apart. You can actually build a network between them so that you can securely transfer key. And then because today what happens when you transfer data from one data center to another, your only checkpoint you have is all the data is transferred. But we don't know whether the data was copied or harvested on its way from point A to point B, right? And that's what we ensure. Then cloud is a big problem, right? We don't want cloud provider to have keys. Any 2 enterprises can build a network, a QKD network or a PQC network, and then you have the keys with you. And the end users can actually encrypt their data and put it in the cloud with no one having the keys, only the users. So basically what it means is we are creating a quantum secure Dropbox in the cloud. Any healthcare hospitals can actually put their data in the cloud, which is ultimately with quantum secured, quantum encrypted with keys only with the users, but not possible earlier, right? This is again Wi-Fi network. Mobility is not there. A lot of people don't use Wi-Fi because not secure. You have VPN tunnels. We know that today NSA of certain countries can have the technology to break VPN. If you use Chinese VPN products, all the data get harvested and goes to China. We need our own technology. India has its own technology where we have the PQC and our Tropos, which is our QRNG seeded post-quantum cryptography VPN tunnel, which is unhackable. We can create over Wi-Fi, Li-Fi, and anyone we can give a secure terminal. And then as we speak, we are doing 4 projects, and this is ready technology. It can be deployed in 24 hours. Then a very interesting thing, because I saw a lot of professors and students from the college, what India needs is a lab, right? Proven lab, tested lab. Today's India's first quantum lab is available in Military College of Telecommunication Engineering in Mao. You probably would have seen 2 weeks ago, it was inaugurated by Chief of Army. That lab was set up by Qulabs. And as we speak, we are setting up 2 more labs there. And the whole idea is you have QKD hardware at the back end. We will give you a front end, which we call it Critical Analysis Research Platform. You can log in anywhere remotely and you can run experiments. We have given 20 canned experiments. We have also exposed an API where users can actually use those APIs to create their own experiments. So you can run experiments, you can take reports, you can change parameters of QKD. You can change distance, you can change DLI parameters, you can change bias and a number of other distances and so on, right? And you can see the impact on QBER and all the different parameters that we talk about are important in quantum tech. This is again technology available. And when I'm talking about available means you go to a government e-market portal, you click there, these products and along with the cost is available there. You click there, product will be delivered to you. Right? And some of the quantum security application today, we are talking about video conferencing, messaging, VPN over Li-Fi. I talked about it. We can protect all the cloud apps. If any bank, any healthcare institute that has, we have an email security, Outlook security you want, we have a plugin, we give you that, you click there, and then email is secure, end-to-end, right? And what I'm talking about is end-to-end security quantum. There's nothing in between. Encryption of data at rest. I can encrypt data at rest, which means I can actually make ransom out of ransomware. Because if I'm encrypting your data using quantum key, the ransomware guys may put another encryption on top of it, but he can't take away the data and he can't decrypt the data. So his incentive to do ransomware on your data goes away, right? So we take off that. With email, we take care of the phishing attacks. And now we have also gone to the endpoints. So we have a product, a chip that we can put in IoT and endpoints today, and we are doing that for mobile devices. We are doing it for some of the drones today, and then a blockchain. We are working with customers where we have actually one customer is already live, where on the blockchain nodes we put our technology and secure the private key so that the 51% attack that is theoretically possible on a blockchain is not possible anymore, right? So what is our offer today? That is, reach out to us for setting up quantum labs with real products. We also have beautiful simulators that you can use to learn, experiment, and then change. We also do demos for products and solutions. You want to call, we are happy to do demos for you. We are happy to do a small POCs and field trials for you. We are right here in Bangalore and MG Road. That's what I wanted to share. So because I had less time, So I just rushed through it, but I hope I'm happy to answer the question when my time comes.
Thank you, Gupta ji. Wow, really, it is a fantastic presentation.